Hey there, so in this video we're going to take a look at a short lesson on circumference of a circle. Now this might be a topic that you've learned about a little bit in the past, so we're just going to start with the easy stuff, make sure we're all on the same page, a couple of quick formulas to learn about using circumference of a circle. So first things first, the definition is that the circumference of a circle is the distance around the outside of the circle. And because it's measuring a distance or length, it's really a one-dimensional unit like inches or feet. It's the distance around the circle. If you were to start here and walk your way around the circle to where you started, then you've walked around the circumference. So that distance that you went, that's the circumference of the circle. There are two basic formulas that you should maybe already know about circumference. And it depends on whether you know the diameter of the circle or the radius of the circle. Remember that the diameter is the distance across the circle through the center. So it's the distance of a chord that passes through the center. And the radius is half of the diameter. So that's the distance from just the center out to the edge of the circle. If you know your diameter of your circle, then the circumference is just pi times the diameter. And if you know the radius, well, you would have to double that and use 2 times pi times the radius. So these are your two formulas to find or use circumference. It's either pi times the diameter or 2 pi times the radius. So here's a couple of quick examples of finding circumference. So let's say I've got this circle here that has a diameter all the way across of 16 feet. And if I wanted to find the circumference, well, all I need to do is take pi times the diameter, which would be pi times 16. And if I ran that through on a calculator, let's see, what's pi times 16 would be about 50.3 feet. There's two different types of answers that you might get for a circumference. One of them is called an exact circumference, and that would be using pi and leaving it as the symbol pi. So the circumference 16 pi feet is considered the exact circumference. It means we don't round it, we don't put it in a calculator and estimate, it's just 16 pi. Whereas 50.3 feet, if you actually use the pi button on a calculator, you're going to get a decimal that's rounded. And so this would be considered an approximate circumference. Using pi as the symbol pi as an exact circumference, and using the pi button and rounding, that's approximate. If you knew the radius of the circle, like in this case, we have a radius that's 10 centimeters. Well, we would use this other formula that the circumference is equal to 2 pi r. So you'd substitute in that radius, which would be 10. And that would give you, well, if you're multiplying this out to be the exact answer, because multiplication is commutative, I could multiply the 2 and the 10 first, and then leave the pi on the end. And so 20 pi centimeters would be our exact circumference of the circle. If we went to the calculator and typed in 20 times pi, well, that would be an approximate of about 62.8 centimeters. I'm not really picky at this point of whether you keep things as exact or approximate. We'll be mostly working with approximate circumference in this case, but I might ask you about one or the other. So it's important to know both of those. So there's a couple examples of using the formulas to find circumference. But one other thing we can do is use that formula to work backwards. If we already know the circumference of the circle, then how do we find the diameter or the radius of that circle? And essentially we can use the formula depending on if we're looking for diameter or radius, just plug in the part that we know and then solve for the part that we don't. So in this example, let's say I've got a circle that has a circumference of 42 pi yards. So that's an exact circumference. If I want to find the diameter, well, I'm going to set up the formula that circumference is equal to pi times diameter. Now I'm going to plug in the part that I know, which is the circumference C. So in for C, I'm going to substitute 42 pi, and I'm going to leave the other side as pi times d. Well, since I'm solving for the diameter, I would need to get this d here all by itself. And since this is showing multiplication, I would divide both sides by pi. And in this case, the pi's will sort of cancel out, divide out to become 1. And so 42 yards would be your diameter. If I'm going to find radius, in this example, I have a circle with a circumference of 200 feet. And I want to know what's the radius of that circle. Well, this time I'm going to use the C equals 2 pi r formula because we're looking for the radius and not the diameter. Well, I'm going to substitute in what I know is 200 feet is the circumference is equal to 2 pi r. I'm solving for radius, so I want to get that r all by itself. And so I need to divide away the 2 pi on both sides. So I'm taking 200 divided by 2 pi, and that's going to give me the radius of that circle. So on a calculator, we'll do 200 divided by 2 pi, and we'll get about 31.8 feet for that radius. Now, there's a really important thing to know about how your calculator works when you do this step and divide by 2 pi. In your calculator, you need to type in parentheses around that 2 pi. Because if you just type in your calculator 200 divided by 2 pi, your calculator doesn't know that you're dividing by both the 2 and the pi. It's going to go left to right, take 200 divided by 2, and then multiply by pi. Well, that's not what we want to do. So what you'll need to do is put 2 pi in parentheses, and now your calculator knows that you're dividing by that whole product and not just the 2. All right, if you want to see for yourself, I'm going to type in 200 divided by 2 pi, and I've got 314.15. But if I do 200 divided by parentheses 2 pi, I'm going to get something different. I'm going to get 31.8. So make sure dividing by 2 pi, put it all in parentheses. All right, well, next we'll take a look at a couple examples of using circumference in some different ways, kind of apply circumference to something new. All right, now how we can apply circumference in some different ways, we'll look at some scenarios where we'll have a circle that's being, representing some sort of real life thing, like maybe a car tire and how much that car tire spins. So we'll start with that example. If we have a car tire, which, hopefully if it's made right, should be a circle, when that car tire rotates one full time, the car would travel the distance that matches the circumference. One rotation, you've driven whatever the circumference of that tire is. And so if it rotates many, many times, we can just take that circumference and multiply by the number of times it rotated or revolved. And what we end up with is a formula that shows that the total distance that a car or a circle, whatever it would be, travels, is the circumference times the number of revolutions or rotations. So let's say that in this car tire, maybe we have a diameter that's 2.5 feet. That's a pretty big tire. Maybe that'll be a truck tire. So if it has a diameter of 2.5 feet, and let's say that this car tire, this truck tire goes through 10 revolutions. That means it spins completely 10 whole times. Well, how far does that truck travel if the tires rotate 10 times? Well, we would need to find the circumference, so then we could multiply by those 10 rotations. So the circumference of this circle, since we have the diameter of 2.5 feet, would be pi times 2.5. And let's see, that's going to turn out to be pi times 2.5. That's about 7.85 feet. So when that car tire or truck tire spins one time around, the car or truck travels that far, 7.85 feet. Since it has spun around 10 times, we would take that circumference, 7.85, times the number of revolutions, 10, and that car or truck would have traveled 78.5 feet. So that's how you can use the circumference to find a distance that's traveled if that circle is spun around multiple times. All right, we'll talk about a quick example of how to go backwards. So let's take this truck tire and say, well, let's say that truck drives a mile. Well, how many times does the tire rotate for that truck to drive 1 full mile? So the question here is how many revolutions to travel 1 mile? Well, important thing is to make sure these units match. So if we're looking at the diameter in feet, I don't want to look at this in a mile. I want to convert that to 5,280 feet. Got to make sure those units match. So we'll take this formula that the total distance equals the circumference times the number of revolutions. Substitute in the parts that we know to solve for the part that we don't. So the total distance that it traveled would be 5,280 feet. Earlier, we solved and found that the circumference was 7.85 feet times the number of revolutions. That's what we don't know. So let's just use a variable to represent that. I'll just call it x right now. So just one step. Solve for x. We'll divide by 7.85 on each side. And my calculator, there it is. Let's see what we get. 5,280 divided by 7. Oops, that should be 85. Switching numbers around here. 7.85. And that is 672.6. So for that truck or car to drive 1 mile, that tire needs to spin that many times, 672.6 times. All right, we'll take a look at one last quick example of applying this. So let me erase this stuff here. All right, so since we've kind of been off school for a while, I've had a lot of time to get back into one of my hobbies, which is to collect records. So I got to thinking, well, a couple important things to know about records are that, these full-size ones, they are 12 inches of a diameter. And when you play them, they have to spin 33 times a minute so that the speeds match up and the sound's correct. So we got 12-inch diameter, we got 33 rotations per minute. So let's say I'm going to go and sit down and listen to this record. Let's say I set it down and maybe a spider jumps on the very edge of that record and it's spinning around and the spider's just, riding it around. It's like an amusement park ride for the spider's perspective. So my question is, this record will take 23 minutes to rotate around and play the whole side. So my question is, how far does that spider travel altogether while I'm listening to that side one? So here's what we know about it. We have my marker go. There it is. So we've got a circle. that has a diameter of 12 inches. And this is going to rotate 33 times every minute. And this side of that record is 23 minutes long. So the question is, if we've got a spider here sitting at the edge, how far in all is it going to travel in those 23 minutes? Well, what we need to know is that the total distance is equal to the circumference times the number of rotations or revolutions. So we need to solve for a couple things. We're looking for this total distance. Well, let's find the circumference. Because we know the diameter is 12, we can take pi times 12, and that'll give us the circumference of the record, which is 37.8 inches. If you punch that in a calculator. We also need to know how many times will this record rotate while that side plays. So every minute, it's going to rotate 33 times, and it's going to play for 23 minutes. So the rotations will equal 33 every minute times the 23 minutes that it plays. And so this record is going to rotate 759 times during those 23 minutes. So the total distance then would be that circumference, 37.8 inches, times that number of rotations, 759. 37.8 times 759. So that is going to travel 28,690 inches, approximately. Let's see, I'll divide that by 12. How many feet is that? That is 2,391 feet. So that's almost half a mile it is traveled while that record plays. So a quick recap, the things you should be able to do from this lesson are calculate a circumference and calculate a total distance depending on how many revolutions a circle makes, and also work backwards. If you know the circumference, how to find the radius and the diameter.